Right now, without touching a single physical button, you could lose access to every photo you have ever taken, every document you have ever written, every message you have ever sent, and recover all of it completely within minutes on a brand new device you have never used before. That is not magic. That is not luck. That is cloud computing. And it is already so deeply embedded in how the digital world works that most people only notice it exists when something goes wrong. Welcome back to Technology in a Minute. Today we are answering one question that sits underneath almost every digital technology we have discussed in this series. What is cloud computing? How do we use it in the digital world and in daily life? And why has it become the invisible foundation that telecom networks, IoT systems, financial platforms, and AI applications all depend on to function? Here is why the timing of this episode matters. Every technology we have covered in this series lives somewhere. The Football AI Pro system analyzing tactical patterns for 48 World Cup teams, it runs on servers. The SBA Core network managing Ethiopia's 5G connections, it runs on servers. The ECX platform processing commodity trades, it runs on servers. The blockchain systems we discussed for remittances, they run on servers. The IoT sensor data streaming from agricultural fields, it is stored and processed on servers. The question is, which servers, where are they, who manages them? And why does it matter whether they are in a building down the road or on the other side of the planet? Think about electricity. A century ago, every factory that needed power had to build its own generator, hire engineers to run it, and maintain it continuously. Then the electrical grid was invented, and suddenly any factory could simply plug into shared infrastructure and pay only for the power they used. Cloud computing did exactly the same thing for computing power. Instead of every company, every government agency, every app developer building and maintaining their own servers, they plug into shared computing infrastructure and pay only for what they use. That is the idea. And by the end of this episode you will understand exactly how it works, why it has transformed every industry it has touched, and why telecom in particular cannot function at modern scale without it. Let's start with what cloud computing actually is, because the word cloud is one of the most misleading metaphors in the history of technology. There is no cloud. Not literally. The cloud is not a weightless, ethereal thing floating above the earth storing your data in the sky. The cloud is buildings. Massive, warehouse-sized buildings filled floor to ceiling with servers, powerful computers that store data and run software. These buildings are connected to the global internet by fiber optic cables carrying data at the speed of light. These buildings are called data centers. They require sophisticated cooling systems to prevent the servers from overheating and have multiple layers of security. They are distributed across dozens of countries to ensure that if one location fails, the data remains available from another location automatically. When you save a photo to Google Photos, it travels to one of these buildings and is replicated across multiple locations simultaneously. When you open that photo later on a different phone, the reverse journey happens in milliseconds. It was always in that building. As of 2024, the global cloud computing market is valued at over $600 billion annually, and it is growing rapidly. Amazon Web Services, Microsoft Azure, and Google Cloud together host an estimated 60% of the world's cloud workloads. The cloud is not a technology of the future, it is the infrastructure the present already runs on. Cloud computing has three distinct service models, and knowing which model is being used tells you exactly what is happening under the surface. The first model is Infrastructure as a Service, IaaS. Think of it like renting an empty warehouse. The building is there, the electricity is connected, but what you put inside and how you arrange it is up to you. The second model is Platform as a Service, PaaS. Think of it like renting a fully equipped commercial kitchen instead of an empty warehouse. You bring your recipes and your ingredients, your code and your data, and focus on building the product rather than setting up the kitchen. The third model is Software as a Service, SaaS. This is a complete, ready-to-use software application delivered over the internet. You do not install anything. You simply open a browser or an app and use it. Gmail is SaaS. Microsoft 365 is SaaS. Zoom is SaaS. Before cloud-based SaaS, companies had to purchase physical disks, install software on every computer, and hire IT staff to manage updates. Today, the same company logs into a cloud platform for a monthly subscription fee, with software maintained entirely by the provider. IaaS gives you the building, PaaS gives you the equipped workspace, and SaaS gives you the finished product. Together, these models have made enterprise-grade computing accessible to organizations of every size, in every country, at an impossible cost structure. The cloud is the foundation beneath every digital service you use every day. Now let's talk about what cloud computing actually changes for real people, real businesses, and real telecom networks. Because the human and economic story of cloud computing is where its true significance becomes clear. Start with telecommunications, because this is the connection most people never make, and it is the most important one. Cloud computing is not just a business tool but the operating system of modern connectivity itself. Every telecom network, from 2GBSCs to 5G SPA architectures, generates enormous quantities of data. Every call, every data session, every billing event produces records that need to be stored and processed in real time. A national operator like Ethio Telecom generates data volumes that no on-premise infrastructure could handle efficiently or economically. Cloud computing solves this in three specific ways that are fundamental to how modern telecom operates. The first is NFV. This allows network functions, which previously required dedicated hardware to run as software on standard cloud servers. Think of it like the difference between a dedicated calculator and a general-purpose computer that can run any calculation in software. NFV means an operator can deploy new services and scale them without physically installing new hardware at every location. This makes the 5G SPA architecture possible. Core network functions run as virtualized services rather than dedicated hardware boxes. The second application is real-time analytics. Cloud platforms process billions of data points to identify congestion patterns before they affect users. It detects faults in milliseconds, predicting failures before they cause outages, and optimizing traffic routing dynamically. Without cloud-scale power, this analysis would take days, by which time the congestion has already frustrated users. With cloud computing, it happens in real time, continuously, and automatically. The third application is customer experience management. Every time you call customer service, a cloud platform is managing that interaction. It personalizes your interaction based on history, routing it to the right system and logging it for quality monitoring. The scale of responsiveness subscribers expect is only possible because cloud computing handles the data processing. And here's the secret. Cloud computing makes AI accessible to organizations that could not otherwise afford the infrastructure. Training AI previously cost tens of millions in hardware. Cloud computing changed that equation entirely. Startups and researchers can now access the same AI infrastructure as a Fortune 500 company on a pay-as-you-use basis. This is why Football AI Pro can deliver real-time tactical analysis to nations of vastly different financial needs. The processing happens in cloud data centers, making technology accessible regardless of where the team is based. Now we must be honest. Cloud computing carries genuine risks and challenges that require understanding clearly. The first challenge is dependency and sovereignty. Running critical national systems on foreign cloud services raises serious questions. If a provider experiences a major outage, it simultaneously affects government agencies, banks, hospitals, and telecom operators. In 2021, a single outage took down major services for hours, highlighting the vulnerability of shared infrastructure. For Ethiopia, deciding which providers host national data and under which legal jurisdiction is a strategic policy question. The second challenge is latency. Cloud performance depends on the speed of the connection between the user and the data center. When data centers are thousands of kilometers away, every interaction introduces a round-trip delay that affects responsiveness. This is why edge computing has emerged, placing nodes closer to users to reduce latency for time-sensitive applications. Applications working seamlessly in Frankfurt may respond noticeably slower for users in Addis Ababa connecting to other continents. The third challenge is cost structure. Cloud computing replaces upfront capital costs with ongoing monthly subscription fees. For organizations with limited budgets, this shift to operational expenditure is not always straightforward or sustainable. Paying for services in US dollars or euros creates real barriers in economies where foreign currency access is constrained. So zoom out for a second. What does understanding cloud computing actually mean for Ethiopia, for the digital economy being built right now, and for your daily life in ways you may not have fully recognized before today? Here is the thread that connects cloud computing to every episode. The BSC and RNC that coordinated mobile calls, their management systems run in the cloud. The towers delivering 4G and 5G connectivity run in the cloud. The ECX platform paying Ethiopian coffee farmers fairly, it runs in the cloud. The ESX Securities Exchange processing investment transactions, it runs in the cloud. The blockchain remittance systems reducing fees for migrant workers, they run in the cloud. The IoT sensor networks monitoring soil moisture in farmland run there too. The AI systems coaching national football teams and analyzing tactical patterns, they run in the cloud. Football AI Pro, the shared intelligence platform, runs there. The cloud is not one technology in a list of technologies. It is the layer underneath all of them. Remove it, and you lose everything. For Ethiopia, cloud computing represents both an extraordinary opportunity and a strategic challenge that requires deliberate, informed decision-making at the policy level. The opportunity is access. Cloud computing eliminates the need for massive upfront infrastructure investment, allowing organizations to access capabilities for a fraction of the cost. African cloud infrastructure growth, as Microsoft Azure and Google Cloud have all established or announced African data center regions in South Africa, Kenya, and Nigeria. The strategic challenge is sovereignty, where that infrastructure sits and under whose legal jurisdiction becomes a matter of national security as much as technology policy. Cloud computing is not a passive infrastructure. Designing architectures, managing security, and optimizing costs are specialized skills in acute shortage across Africa. Ethiopia's 5 Million Coders initiative is directly relevant to building the cloud skills base. Every certified engineer is a direct contributor to national capacity. Summary: cloud is delivery of computing services over the internet on a pay-as-you-use basis. It operates through 3 models: use, PaaS, and SaaS. Everything in the digital world runs somewhere. Now you know where and why it matters who controls that somewhere and how close it is. If that understanding matters to you, subscribe and turn on the notification bell. Join the community of people who start every week genuinely informed. Next episode, we go inside artificial intelligence. When an AI affects your job or medical diagnosis, how does it work? And who is responsible?